Okay, and the third and final video on special right triangles, okay, is we're going to put them together in expressions. Okay, so they were pretty easy to begin with. Okay, so now you're going to have expressions such as multiplication of two functions together, and then subtraction or addition. There won't be any division. Okay, so cosine pi over 3. So that's why I have my triangles already drawn out on a piece of paper. Okay, if obviously you're supposed to memorize them, but if I didn't have them memorized, or I could simply redraw them very quickly. So pi over 3, I know goes with 60. So for sake of time and for the video, I'm just going to look at the picture that I've already drawn of the 60-degree triangle. And cosine is adjacent over hypotenuse. So adjacent over hypotenuse from this angle of 60, which is right here, okay, pi over 3 goes with the 60 degrees. So adjacent over hypotenuse would be 1 over 2. Okay, so what happens is that this entire expression right here, cosine is adjacent over hypotenuse. So I am looking for that for the 60-degree triangle, which happens to be 1 over 2. Okay, so now we're looking at the next one, which is secant. So this entire expression right here, I now need to look for h over a, hypotenuse over adjacent. Okay, so I'm going to bring back my triangle, still at 60 degrees. Hypotenuse is 2, and my adjacent is 1. Okay, so I'm going to slide this down and I'm going to make this 2 over 1, which it should make sense that these two are reciprocals, that when I multiply them together, I should end up with just 1. Okay, make sure that you write that down, okay, because I still have to subtract something from it. Okay, so it doesn't just cancel and go away. 1/2 times 2 over 1, the reciprocal, and when I multiply them together, it leaves us with a 1. Okay, so now I'm still dealing with this last piece, cotangent pi over 3. So still a 60-degree triangle, which is right here. Okay, and now cotangent is adjacent over opposite. So when I'm looking at the 60 degrees, adjacent is 1 and opposite is radical 3. So I'm going to write down 1 over radical 3. Now it's up to you if you would like to rationalize it first or if you would want to wait to the very end to rationalize it. So we could rationalize it here if we want. Okay, so that's going to give us radical 3 over 3. And then I'm going to put this right here. So 1 minus radical 3 over 3 is essentially what we need to combine. Okay, so what needs to happen is that you guys need to have a common denominator. Okay, so how do we get a common denominator? Well, I have 1 minus radical 3 over 3. So that means that if I make this a 1, okay, because you can rewrite anything over top of 1, my common denominator is 3. So I multiply this by 3 and this by 3, and that is going to equal 3 minus radical 3, okay? I cannot put those together because one's a radical and one's a 3. They're not like terms, okay? So I can only connect them with a minus sign. So 3 minus radical 3, and then you slide over your denominator. Okay, now I have like terms, okay? And a common denominator. Now, please, not like terms, I'm sorry. We just have a common denominator. Please do not get crazy here and say, oh, now I get to cancel these out, okay? I do not get to cancel out the 3's because then that defeats the entire purpose of getting a common denominator. We cannot cancel the 3's because this 3 now has baggage attached to it, okay? It has this minus radical 3 attached to it, so I cannot cancel them out. I have to leave it like this. Okay, now I will show you an example just for sake of letting you know like when you can cancel something. Okay, so let's say for example I ended up with this. Okay, now this is totally separate. This is just me doing a simplification problem to show you the difference. Okay, because in front of here is just a 1, so I cannot cancel anything here, right? But here I have to look in what I call like the little triangle here from here to here. All of these I can divide by the same exact number, which is a 3. If you can divide all 3 of these in this little triangle by the same exact number, then you can simplify it. So in this case, this would simplify to this 3 becomes a 1 minus 6 divided by 3 is 2, radical 3, all over 3 divided by 3 is 1. So this could just be written as 1 minus 2 radical 3. Okay, so I just wanted you guys to pay close attention to that, okay, when you're simplifying these radicals with the fractions. Okay, so the purple box here, this is going to be left for you guys to try. So please make sure you write that down, and there will be a Nearpod question for you guys to do with that to input your answers. Okay, so just make sure you write that one down. So I'm going to go to this one. Okay, the difference with this one is that there's a square. So I want to immediately show you that the way that we write this is technically tangent pi over 3, and it's that entire expression to the second power. Okay, so it is written like this in trigonometry, but it's actually tan pi over 3 squared. Okay, so sine pi over 6, we need to figure out what this is equivalent to. So pi over 6 goes with a 30-degree triangle. So sine is opposite over hypotenuse. So opposite is 1, hypotenuse is 2. All right, so this entire expression is 1 over 2 plus. Okay, now we want to know what this is inside the parentheses. Okay, we're following PEMDAS, so we can't do exponents yet because we need to know what this expression is. So tan pi over 3. Pi over 3 is 60 degrees. Okay, so I'm looking at the 60-degree triangle, and I'm doing opposite over the adjacent side. Okay, so that's radical 3 over 1, or just radical 3. Okay, so see how this entire thing got replaced. So I did the inside the parentheses. Now I can do exponents. Okay, so if you forget, radical 3 squared, the radical and the square cancel, or just know it's radical 3 times radical 3, which is radical 9, and that becomes 3. Okay, so I have 1/2 plus 3. And at this point, you guys could either write it as 3.5, 3.5. You could write it as 7 over 2. I don't care how you write that. Okay. All right. So hopefully you guys are okay with that. And I'm going to have you guys also complete the purple you try problem for the next two. Okay. Just remember that this would be cosine pi over 4 in parentheses squared minus tan pi over 4 in parentheses squared. Okay. And then this one just means that you're going to go to different triangles, but essentially it's the same. So you figure out what this is, write that down, find out what this is, write that down. They get multiplied, minus, figure out what this is, okay? And then you put them together and make sure that there's no radical on the bottom, okay? All right, and last but not least, I will do this bottom problem for you, okay? Because this one's a little bit tricky, but not too bad. Okay, so let's say we have 2 out front. So all that means is that we need to figure out what this is first. Okay, so we're going to have 2 times, so I like to use parentheses for these, pi over 3. Okay, so pi over 3 goes with our 60. So here's our 60. And again, it's tangent, so it's opposite over adjacent, all right, which is radical 3 over 1, or just radical 3. So I'm just going to put that in here. So opposite over adjacent, okay? And then plus cosine pi over 4, all right? So that is adjacent over hypotenuse. So adjacent over hypotenuse for the 45-degree triangle, okay? I come over here, and that's going to be 1 over the radical 2. Okay, so it's up to you when you want to rationalize it, or you could do it in the beginning or at the end. Okay, so I'm going to do 1 over radical 2 for now, so I have it written down. And then tangent pi over 6, okay, is opposite over adjacent. So pi over 6 is 30, so that means I need to use this triangle. And tangent is opposite over adjacent, okay? So that's 1 over radical 3, okay? Okay, so we're multiplying these. So it's up to you if you'd rather rationalize now or wait and do it later. So 2 times radical 3 is just 2 times radical 3. Okay, it's like saying 2 times x. You would just have 2x. Okay, plus, and then it's 1 over radical 2 times radical 3, you just multiply whatever's underneath the house. So it's radical 6. Okay? Then from here, I would rationalize before you get a common denominator. Okay? So if I rationalize, okay, I get radical 6 over 6. So we have 2 radical 3 plus radical 6 over 6. So from here to here, just rationalize. Okay, so then that tells me we need a common denominator. Okay, and our common denominator is going to be 6. So I multiply this by 6, and I multiply this entire thing by 6. Now, when you multiply that by 6, it's just by the 2, okay? It's not like 2 to the 2 and to the radical 3. There's no plus or minus sign here. So it's just 2 radical 3's multiplied by 6. So that would be 12 radical 3. So I have 12 radical 3 over 6 plus radical 6 over 6. And I'm going to slide them across. 12 radical 3 plus radical 6 over 6. And once again, I'm going to take a look here. And if I look at like my little triangle, there is nothing here because there's a 1 in front of radical 6. I can't cancel anything. So this is essentially my answer. I can't do anything at all. I have to leave it like that. Okay, I cannot divide the 12 into 6 because this is all attached to baggage. I cannot combine radical 3's and radical 6's. Okay, that is all I can do. Okay, so I just leave it just like that, and that's the way we keep it. Okay, all right, so you're going to go back to Nearpod and finish up the 3 U-tries. Okay, and I will type those into Nearpod so that you can answer them, and that will conclude your lesson on special right triangles. Great job.